I'm Anil Kumar. Welcome to my series on advanced functions. I've made a test paper on Unit 1 and here is question number 13. Graph the function f of x equals to 2 to the power of absolute value of x minus 2 plus 1. Describe 5 characteristics of this particular function. So 2 to the power of something which is an absolute value plus 1 is your function. You can always pause the video, answer this question, and then look into my suggestions. Now, in such questions, I'll prefer that you create some table of values, right? So let's make a table of values here. So we'll have different values of x, and for that, we are going to calculate the y values. So let's take some x values. And for each x value, we'll calculate what is 2 to the power of absolute value of x minus 2 plus 1, correct? Okay. So let's begin with when x approaches minus infinity. So if x is very large value, then I get 2 to the power of infinitely large plus 1. So we know this function is approaching positive infinity. Right? Similarly, we can also think about the end behavior. What happens when x approaches positive infinity? In that case also we see it will be approaching positive infinity. So both sides up. So that is the end behavior. And now let's talk about the points in between. So if I take a value of x, let's say minus 2, then what do we get here? We get 2 to the power of minus 2 is minus 4. Absolute value will be positive always, right? So we have this, which is 16 plus 1 is 17. If I take minus 1, I get 2 to the power of minus 3. Absolute value is plus 3 plus 1, which is 9. For 0, we get 2 to the power of 2 plus 1, which is 5. For 1, we get 2 to the power of 1 plus 1, which is 2 plus 1 is 3, for a value which is 2. 2 minus 2 is 0, so we get 2 to the power of 0 plus 1, which is 2. And then for 3 minus 2 is 1, so we get 2 to the power of 1 plus 1, which is 3 again. And for 4, it will be 4 minus 2 as 2, so 2 squared plus 1, which is 5. So you see these values are repeating, so for 5 will be 2 to the power of 3 plus 1, which is 9. Lowest being at 2, right? So that becomes your local minimum, correct? Now with these values, let me sketch the graph here, and then we are going to write down the characteristics. We see that all the values will be positive, right? Since it is 2 to the power, it is more like a parabola, which shifted 1 unit up, right? And symmetric about this particular point. So we could actually, we know that the minimum is at 2, at, let's say this is 2 for us, right, 2, 2. Then the graph will be kind of like this. You see that? So that is how it is going to be, and this value here will be 2, as we can see, and the y-intercept will be at 5 when x is 0. Is that clear to you? So that is how you could actually graph the function 2 to the power of absolute value of x minus 2 plus 1, correct? Now let's do the second part and writing characteristics. So the first characteristics which I'm going to write here is the domain. So domain of the function is x belongs to real numbers, right? The second one is the range. So as far as the range is concerned, y belongs to real numbers. However, we see that the y value is always greater than or equal to 2. Correct? Now end behavior. End behavior, as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y also approaches positive infinity. Then we could have increasing and decreasing interval, right? So let's write increasing interval. So it is increasing from 2 to infinity, correct? And then we can write decreasing interval. It is decreasing from minus infinity to 2. Okay? So that is how we could write different characteristics for this particular function. Okay? So I hope it makes sense. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best. Now here is question number 14, which says express circumference of a circle as a function of its area. So let's write down the two equations. When we are considering a circle, then in that case area is equal to pi r square and circumference is 2 pi r, correct? So these are the two relations. We want to express circumference of a circle. So let's call this circumference as c and area is a. So we want circumference as a function of area. So we know c is 2 pi r. Now to get this as a function of a, we can actually isolate r, right? So from this equation, we can work what r is in terms of a. So let's do that part first. So we get a is pi r square. So a by pi is basically r square. So square root of a by pi is basically equal to r. We have to take positive values since r is always greater than or equal to 0. So that becomes the value of r. So we can now write c as equals to 2 pi, the value in terms of a is square root a over pi, correct? So that means this is divided by square root of pi. So we could say this c is 2 times square root of a pi. Is it clear to you? So that becomes the relation. So we can say circumference as a function of area is equals to 2 times square root of pi is a constant, so it's better to write pi first. So that becomes our relation. Is that clear to you? Right? So if I equate, let me call this as equation 1, this as equation 2, we get this from equation 1 and 2. We substitute the value of r here to get our solution. Correct? So that's how you could do it.